Alright guys, today I will be showing you how to use SQLite with the Java Swing as the GUI. The first thing that we need to do is we need to jump out to our internet browser and download the Jdbc SQLite jar, which can be found at this link right up here. And there will be a link to that in the description as well. So first we'll head out here and we'll download whichever is the latest one. In this case here we've got version 3.2, and we'll keep. Now once that has downloaded, we can come back into our Eclipse editor and right click on the JRE system library, and we're going to go into the build path, configure build path, add external jars, and there is our SQLite JDB and then your version. Go ahead and click open and OK. Now what this does is it creates basically the reference to that jar so that we can use all of their internal classes and stuff like that, so that we can actually get connected out to our Java or our SQLite database from Java. Now, I've already done it, but if you haven't, you also need to create a new Java project. Go ahead and create a package and a class file. I just called my main one here driver. And we're going to go ahead and start by building the SQL backend. So the first one we'll make is the creation of the table. So we'll do a public void create SQL. And this one does not need any arguments. And we will go ahead and register our class with Java here so that we can initialize basically the class for all the static references for name. And the class that we want to initialize is going to be the org.sqlite.jdbc, and we'll put that in quotes. Class not found. So for temporary, we'll go ahead and we'll do a class not found exception. The next thing we're going to do is make our connection, which I'm going to call con, and that will be our driver manager dot get connection. And in here is where we give it our connection string, it's called. So the default that we'll use is JDBC colon SQLite colon the database name dot database extension. So in this case it's just doing test.db. Now that we have our connection here, which we need to import from the java.sql library, and our driver manager, which we're, again, just to be lazy, going to add throws declaration instead of try catch or anything like that. Right now, what the throw does is it allows you to pass that error message up the stack so that you can handle it in your own way. For this example, we're going to assume we just aren't going to have any errors, and we're just going to throw the exception and actually not handle it in the stack at all. So what we can do next is we can create a new statement. And what this statement is it's going to be our create table option, which create statement. And this is the actual SQL code that we can use here, if I'd spelled it right. And we will go ahead and import the java.sql again. And then we can use our variable stat or statement to execute a update query. So it will be execute update. Now, what we have to put in here is our actual SQL call or our SQL code that we're writing. So in this case, I'm going to say create table if not exists, and then the table name, which in this case is people. I'm going to give it a name and occupation as our two fields. And what the create table if not exists does is it says if this table is already in existence, so if the table name is already there, don't create this, just use the one that's there. If it's not there, go ahead and make it so that we have somewhere to put some data into. Now the next thing that we're going to do is create a prepared statement. And what that will let us do is avoid something called MySQL injections, which is very important, because basically what a MySQL injection does in the simple sense is it allows an attacker to put in SQL code that you don't want them to have. Like they could put in a drop all or a select all table, and we want to strip that out so that there's no security flaws here. So that's what the prepared statement does. An older version may have been the SQL safe string, but that's no longer used. This is supposed to be a little easier and better here. And we can write our code, which is going to insert some fake data. So we'll insert into our table name, which is people, and the values are going to be question marks, separated by commas there. And the reason that we use question marks is that tells our prepared statement that those are going to be values that we need to make sure are clean, if you will, that they're okay to use. We're going to treat them as text, not as part of the statement itself. And we're going to use the set string here, and the first argument is which slot it goes into. So in this case, when we're inserting into people and we have values, so 1 will be here, it starts at 1, and then number 2 will be the occupation. So it'll go name and then occupation. So for the first name, let's go ahead and use Pythagoras. And his occupation was kind of mathematician. So let's go ahead and put that in too, so it's in the occupation field. And well, we'll put him under number theory, because he worked with a whole bunch of things more along that line. Now what we need to do is we need to add the batch. What this means is that we are basically creating this prepared statement into one command statement so we can run all of our inserts at one time instead of having to do a whole bunch of different ones. And we're going to add to that just a little bit. I'm going to go ahead and copy and paste a whole bunch of these different prepared statements. So here you can see we have tons of them now, and they're all pretty much the same. They're just the prep.setString. We tell it which field it's going into. In this case, it'll be first name. Second, it will be the occupation. So there's a whole bunch of just generalized fake data, if you will, so that we can see what it looks like if we had real data. Now I'm also going to set auto commit to false, so that when we commit this statement, it will actually commit everything all at once instead of doing a whole bunch of opening and closing and opening and closing. And we are going to execute our batch, which is what we have prepared up above. And then I'm going to also go ahead and set the auto commit back to true, because we normally want this to auto commit, because that will be when we execute, it commits each statement one by one. The reason we don't want it here is we have so many so many insert statements. We don't want it to insert one row and then insert the next and then the next and the next. We want to just say insert all of these records all at once. So it saves a little bit of overhead there. And then the last thing that we did is we actually execute our batch, which is what we have added all up here with our prepared statement. And then finally we close our connection so that the next time we want to read and write from the database, we can do that. It doesn't think it's already being used. So we are done with the creating the SQL section. So we will move right along into the next portion, which we should probably populate some data. Now, when I say populate the data, we already created the table and we inserted some generic data. But what we want to be able to do now is actually show that to the user, which is where the Swing Java stuff comes in. So up here, I'm going to go ahead and prototype a few private variables, one of them being JTable, which will also need an import, and I'm just going to call that table for now. And this will be from the Java Swing library. And then I'm also going to go ahead and create a private string array, and this will hold all of our column names. So the first one that we'll have is the row ID. Next one we'll have will be the name, and the third one we'll have will be the occupation. And generally speaking, what we're doing here is we have these elements in our string array that we're going to later use to tell the table how to display the rows. So when we give it a set of data, we give it 3 pieces of data, it will know to put them in the proper fields of going row ID, name, and then occupation. The last thing that we're going to do, which we won't work with for a little while here, is we're also going to create a prototype table model listener. And this is going to throw some errors because we currently don't have anything referencing table model listener. We're going to import it, and I'll show you what we do with this later. This will come down to when we're actually editing and changing the table and manipulating our MySQL, and we need to be able to listen for events like the data being changed. So at this point now, we can go ahead and start writing our populating SQL stuff. And this we're actually going to need some arguments for the population. We're going to need a JTable so we know what table we should be updating. So when we read all of the results from our SQLite database, this will be the table that we populate it all into, so that we don't just have data lying around randomly. So again, first thing that we do is we're going to go ahead and we're going to register our class, which is the org.sqlite.jdbc. And this will all be the exact same as in our connection. So we'll do a new connection con equals driver manager, and then our connection string, which is the Jdbc SQLite test DB. What did I type wrong? Driver manager dot get connection. And again, I'm just lazily throwing the error messages up the stack, not to be handled or dealt with at this time. So now we have our connection statement. We're going to create another statement, and this is the exact same as what we were doing for the insert and the create table. We're just creating a generalized statement, and then we're going to execute a query on that statement. And what this query will be is actually a select statement. So what we're going to say is select row ID, comma, all, which is the asterisk, from our table. Now, the reason that we need row ID is later we need a way to identify what record they're editing and changing, and we're going to use the row ID to do that because it's built into SQLite. Version 3 and higher gives you the option of an auto increment ID, but it's normally suggested to not use that unless you specifically need it. The row ID will work perfectly fine for what we're doing. And now we need to loop through what's called the result set, or the RS in this case is the variable we're going to be using. And what the result set is, here we go, result set RS equals. So when this runs through, it is going to get basically all of that information in this data type called result set from the SQLite table, and then we need to loop through it. So what we can say is while RS has the next item available, so while there's still data that hasn't been processed, we're going to process it. And we're going to add an object here, and we're going to call it row, and it's going to be a new object using our column length. So what it is every time we create a new array, because it's an array of objects is what we're making here, we need to tell it the actual size because it's a true array, so it sets aside that much room in memory. And what we're going to say is we know that there's going to be three records coming, or three fields coming out of the database: the row ID, the name, and the occupation. So what we can do as a lazy method, instead of writing 3 here, is we can just say we're going to be displaying 3 columns, up here. So we can use the column's length for how big our array needs to be. And then we're going to create a for loop to actually loop through each one of the individual records here, which is in the row data. So while so in I equals 1, while I is, let's see, less than or equal to columns.length, go ahead and add 1 to I. Alright, so now what we need to do is we need to tell our row I minus 1 because by default it starts at 0 and we started our I at 1 for readability. We are going to go ahead and have that array entry, which in this case the first one will be 0, the next one will be 1, and so forth, is our result set.get object. And then we need to tell it what object we want, which in this case is I, because we're looping through each result here. So now that we've got that, we now have this row object, which contains all of our line data, and that will make sense once we actually display it. So the next thing we need to do is we need to cast our default table model, and this will basically be what's handling all of the data, and we need to get the model from the table, and then we need to go ahead and insert row, which I may have typed that wrong. Let's see, default table model, and we are using the table.getModel, and then we are going to insert row rs, or our result set, dot get row minus 1. There we go. And that's basically, again, just telling it to start there at the we assume that the row would start at 1. It actually starts at 0, so we minus 1, and then we give it the row object here, which every time we loop through, we're recreating that object under the same name, which will reuse the memory and create a new object to populate in our table list. So the last two things we need to do is we need to actually close the result set as well as the connection, closing the connection will let us use it again later, the same database, and we close out the result set to avoid memory leaks. It should be closed when con.close is called, but that's just some general nice cleanup there. So what we have now is we can go through and we create our table, then we populate it, the SQL table itself, and now we've used this prototyped element table and we've populated that with some data. But we actually need to work on being able to show that table so that we can see what's happening. So before we create our update SQL and our delete SQL, let's go ahead and create some of the GUI stuff here. And to do that, we're actually going to use what's called a constructor. And what the constructor is that is something that is called whenever the class is called. I need to update my Eclipse. It keeps bouncing around on me. So we create a public driver, and this is telling it that it is the constructor for this class. So the driver will be whatever your class name is. And the first thing we're going to do is create a default table model. And again, this is generally speaking what is going to handle all of the data that we're putting into this table. And the arguments in this case is going to be the columns, which we defined up above, and then the data. Now, in this case, the data is 0 or null. We're not gonna put anything in it yet because we're going to use our populate SQL call down here to fill the data with information that's helpful. The other thing that we need to do is we prototyped our table variable, but we haven't actually assigned it to anything. So now we're going to assign it to a new JTable, and we're going to tell it that the data model is going to be our model that we just created, which will let us manipulate and add things there as we go. So we're going to drop into our try statement, create SQL, in the hopes that we will just create the table if it doesn't exist. And then we're also going to add a catch exception. And again, this is just if you have errors or if you're making a real application, you want to handle errors. But I'm pretty confident this is going to work for what we're doing. So I'm pretty much just ignoring and passing up any errors. And I'm going to copy the exact same line. And after we create the SQL, I'm also going to populate the SQL. And I'm passing it the table of the argument, which is our global prototype, which we've now assigned with a data model here, so that all of that should work. Now, the good news is at this point, if we run the program, we create a table, and we populate our database, and all that works all fine and dandy, but it's still not going to display because we haven't told the Java Swing to actually do anything yet. So what we want to do is go ahead and set a couple properties here for the JTable, which we call table. So the first thing I'm going to do is I'm going to set cell selection. Let's see, cell selection enabled, and I'm going to make that true, which means that we can edit and select cells within the table. And then I'm going to set the preferred scrollable viewport size, and it's going to have to be a new dimension, and this is going to be basically at what point should we start scrolling the data. At what point do we consider it overflowing the screen and allow it to scroll. And then we're also going to set fill viewport height as true. And again, this all just has to do with basically how the data is displayed. The next thing that we'll do is we will create a Jstroll pane. And what this scroll pane does is it allows us to actually scroll that information. If you've ever been on a website or something and you scroll down or you scroll to the sides, that's exactly what we're doing here, just within our application. And then we're going to set some properties on the scroll pane as well. First thing we're going to do is we're going to set it as visible which will be true because we want to be able to see it. And then at this point, we are okay to go ahead and get Pane content. So get content Pane, and we are going to add our scroll pane, which is what we just created, and we're going to use something called a border layout in this case, which is basically how it chooses to display on the content itself. So there are a whole bunch of different options that we can use for the layouts. There's flow, there's border, there's grid. I think those are the most common. There's also something called wrap, I think. But these are the ones that we're going to use for right now. And what the page start means is basically it's going to be at the first part of the form. It's going to fill all of it. We're also going to use some other things like line start and center, and they've got a whole bunch of different options that you can do. But that goes down more into just the design of how you want it laid out when you're done. Now the next thing that we're going to do is we're going to have a new instance of our class, and we're going to call it frame, and it's going to be what we use to actually display all of our data. So when we do that, we want to go ahead into frame and set the default close. So it'll be frame dot, sorry, that's lowercase, set default close operation, and what we want to do is tell it to exit on close. Alright, now once we get this set, the other thing that we have to do is we have to do the frame.pack right here, which basically grabs all those components, puts them all together in one package. And when we open the window, where do we want it to open relative to? In this case, we want it to open relative to null or nowhere specific. And then we're also going to set the visible to true so it actually shows it. What I had to do is I had to extend the JFrame that we're going to be using, that's our UI, and import it. So let's go ahead and run it and see what happens. Right now, as you can see, what it opens up with is our row ID, our name, and our occupation. And now no data is currently displaying, but it's all packed and ready to go. So let's do a little bit more work on this so that we can actually get some results showing up. And what we should do is look in our folder and see if the table is created. There's our test DB with 8 kilobytes of information in it. Now, I know that a couple of these here, I'm just using Notepad++ to look at it, but clearly some of our data filled. There's Pythagoras with number theory and whatnot. So we know that our database has been created successfully. It exists, it can talk to it, but we're still not getting any data to show up on our form here. So let's look at why. No suitable driver found for JB. That's because I did that wrong. Let's find out where I typed that. Here we go. Jdbc. And there's a whole bunch of data. In this case, it actually has 60 rows is what it's seen. Format and format. So this is ran a couple times. Oh, which makes perfect sense because we're reinserting that information every time we create this, which you don't necessarily want to do. So I guess if we open this again, it's got even more data. So let's go ahead and say, I thought we said create table if not exists. Oh, we did, but then we actually repopulate it multiple times. So basically what happened here is we create our database once, which is perfect, and then we immediately go and we populate it. Every time we reopen the form, we're re-adding the data there. We're repopulating the form. So let's take a look at our create query here. Yeah, so we create the table if it doesn't exist, but then we update and insert these values no matter what. So what I'm going to do is just go ahead and delete the database, rerun this one time so that we have the database with all 20 entries, and then I am going to, from code, just comment out the creation of the table, because once it's created we don't need to create it again. What would be ideal, since this is a data set, would be check if the table exists. If it does exist, don't do anything. If it doesn't exist, then create the table and insert the rows and whatnot. But again, this is test data, so it would depend on how you're getting this information or making it in your environment. So now we can see the data, and that's all fine and fancy, but there's still a few things that we want to do. Probably one of the first things is let's go ahead and create a delete button so that we can get rid of rows. So we'll come up here and we're going to go ahead and create a J button. And let's go ahead and call this delete, and it will be equal to a new J button. Now we need to import our J button library from our Swing components, and let's go ahead and give it a name, or like a text on the screen of delete, which can be just handed as an argument, or you can set it later if you want to. Now the other thing that we need to do is we need to add an action listener, and what this is going to do for us is when we click the button, it's going to actually do something. Otherwise it would show up on the screen and be all pretty, but it wouldn't have any functionality. Listener, there we go. And this is where it gets a little bit more immersive code-wise. We are going to create a class as part of the arguments, and we'll need to import action listener from the AWT events. And let's see, we're going to make a public void action performed, and it's going to take the arguments of action event E, and then we actually need to do something here. Something needs to happen. And that something in this case I missed an opening brace. There we go. That action in this case is going to be to drop the record or delete the record from our SQLite database. I'm just going to clean this up so it looks a little prettier here. Alright. And so in here, this will be a function call to delete SQL. Now, the problem is we don't have any SQL to delete at this point. And even if we did, we need to make sure that some things are happening first, like a record is actually selected. So let's go ahead and say if table dot get selected row is greater than -1, because -1 means nothing is selected, so that means they haven't clicked on anything yet. We're going to go ahead and create, or in this case delete, our SQL field. Since that's not a created function yet, I'm just going to comment it out for the time being. But we're also going to end up needing to pass it what row we want it to delete. And we'll get into some fancy footwork for that in a minute. But the first thing we're going to do is create our actual SQL function here that will let us delete records. So we'll call this delete SQL, and we're going to take some arguments like the row ID, which, although it's an integer, I'm going to pass it as a string because we're going to be displaying it as a string and then converting it back. Doesn't really matter. If you want to use it as all an integer, that would be fine too, but I find this just makes it a little bit easier to work with here. So what we do is we again register our class, which is the same as our connection string above. We're going to connect the same way pretty much every time, so that should become pretty secondhand to you. Jdbc. We're going to create a new connection to our database through the driver manager. Get connection, and then our connection string, which is once again the Jdbc SQLite test DB. Gonna take care of some handling here. So we pass any errors that it throws up the stack. And finally, we are going to create our statement stat, which will be a new connection create statement. Just like that. Oops, sorry, it doesn't need to be a new one. It's going to be the existing connection to it. And we will go ahead and we'll execute stat, not state. And this is actually going to be an update, not a query. So execute update and our SQL code, which in this case will be delete from table, which in this case is people, where the row ID equals, and we're going to go ahead and say row ID and we'll end our statement with the semicolon. Now that we have theoretically deleted it from our SQL table, we also need to delete it out from the JTable. So what we need to do that is we need to go ahead and cast the information of default table model, and we can use the globally prototyped table dot get model, and we're going to go ahead and remove row, and we'll tell it where, which we now need to cast our string that we asked for as an integer dot parse int, and the string, which in this case is going to be our row ID -1. We'll see if I got those all lined up correct. I think I've got some missing. Create default with an L, not a K. I'm really not liking my second keyboard here that I'm using. But with those excuses aside, now we've actually gone through and we've removed the row from the table itself. Which means in our constructor, we can go ahead and actually give it some code, delete SQL, but we still need to tell it which row. Now, just to show you how this works, I'm going to go ahead and hard code it and just tell it to get rid of the third or the fourth statement here, wanting this in a try catch. We're going to surround with a try catch, and because I'm again quite confident this works because I've actually already written this code, we're just going to leave this in here, and yours might be a little different. If you have throws this in your application, you're going to want to start at the most specific error and move to the most generalized. So you'll move from the most generalized error in general, or I'm sorry, the most specific to the most general, so that it will actually catch them and go down the loop. And let's go ahead and see if this works. So let's go ahead and say we're going to be removing this number 4, but wait, we never actually added the button to our layout. So in our constructor here, now that we've added or created the button, and we've also gone ahead and given it a listener function, basically an action to perform when it's clicked, we're also going to add the J button, which we called delete. And then we need to tell it where exactly we want this on the border layout. So it will be border layout. And for the delete one, let's go ahead and put it at the line start. Line start. And that is a little different from page start. Page start is the form. Line start will be the new line. So what it is it will be placed right down here. So when we click that, nothing should happen because we're telling our function here, our listening function, to ignore it if nothing's selected, which we haven't yet. So let's go ahead and select 4 just so it stays close, which is poor format here. We'll delete, and poof, he is gone. Now there's a problem though. If I click delete, it'll delete from the existing rows, but it's not actually deleting any SQL because it's currently hard-coded. So when we rerun it, 4 is gone, but none of the others are. So let's go ahead and see how we can get the actual selected row instead of passing a static string here. We want to pass it some real information. So in this case, the real information is going to be a string dot value of, and that's basically, if you're familiar with like the C# or the .NET, that would be .toString, very similar. We're going to use the table dot get selected row, so that gives us the row that we're working in that we have selected, plus 1, so that it's not at the weird offset, because the JTable starts at 0, but our SQL actually starts at 1, which gets a little confusing. It's kind of nice when it's all standardized, but of course it isn't. And so that will give us the selected row. Let's go ahead and run this and show you how it works. So we come in here and we say, okay, let's get rid of Gandhi here. I'm British enough. And, Oppenheimer kind of created some pretty terrible stuff too. So let's get rid of Oppenheimer. Alright, so we rerun this to make sure, and now Oppenheimer is still there, Gandhi is still there, our tables aren't, so let's look at our SQL. Okay, so after digging around for a little bit, what I did is I went and I just deleted the database to start with, came back, and now what we're doing is we're sending, instead of sending it a static 4, we're calling our function with string.value of table, which is talking about our JTable, get selected row plus 1, and what that is doing is it's saying from our table, wherever the selected row is, add 1 to it because JTables start at 0, SQLite starts its row ID at 1, so now we're changing that conversion, if you will. And we're calling our delete function, which is going in and getting rid of row ID. So we'll go ahead and we'll fire that up. As you can see, it recreates the table there. And I'm going to go ahead and get rid of Peter Singer. And then I'm going to comment out the creation of the table so we don't get a whole bunch of data in there. And run it again. And as you can see, Peter Singer is no more. He is gone. If I get rid of Plato, ID 3, close and reopen, ID 3 or Plato is still gone. So that is all working correctly for our delete statements. And then the other thing I noticed, I accidentally changed this to start when it should be, line end when it should be line start. So let's go ahead and, what else do we want to create? Let's do our listener so that we can update these rows in live time. Now that is going to create quite a bit more code and quite a bit more work here, but I think it'll be worth it. So the first thing we need to do is create a table model listener. And what this is going to let us do is anytime the cell is changed or updated, we're going to override that finishing function and do some of our own work. So what we can start with is we'll drop down here, and we can go anywhere for now. I'm just going to go ahead and add the listener after we add all of our content. And it will be a table model listener equals new table model listener. And if you remember, we defined this up at the top prototyping when we went through and did everything up at the top there. We also are going to create, yes, this public void table changed, and we're adding an override method up here, which is telling Java that this method already exists from the default Java Swing and Java listener here, and we're going to override what happens, so we're taking control of it. So what we want to do is say, and the E is the argument, so if e.getType is equal to table model event.update. Then let's do some stuff. And what the table model event update is let's see if I can get this. Should be turning all fancy colors, but it's not. What the update event means is just that basically they entered the cell, they did something, and they left the cell. That does not guarantee that they changed anything. It just means that they did not hit the escape button. Basically, the form has been validated. So this event, it's very important to know that this fires after the cell validation. So if you're using cell validation, like for example, they can only add integers, they can't add strings. This, and they add an integer instead of a string, or vice versa. It is going to throw an error. It's not going to let them proceed. So that's pretty important to know and to remember, is that this happens after the form validation. So what we'll do for right now is we'll say, if it's an update event, let's go ahead and system.out.print. What we're going to do here is print out basically what row is being affected and what column. So row, and we're going to add string.value of e.get first row, and let's see how this works. So now, theoretically, when we come in here to Brian Green and exit it, oh, we never actually implemented the listener. So underneath that, we need to say table.get model.add table listener, and then this is where we'll use our table model listener that we created earlier. Now that we've actually implemented it, now we run and go into, say, Brian Green. When we leave, it says, okay, it's row 14. And if we take away 1 from 14 to get the starting at 1 instead of 0, that is the correct list here, if you will. So what we can do now that we have our listeners, we need to be able to find out what the old value of the cell was to see if they changed anything, if they've edited it. Now, to do that, we actually have to implement quite a bit of code for a table cell listener. And that is going to require some new actions to be created. So, coming up here a little bit higher, I'm going to do it right under here. We need to go ahead and we need to create a new action. So we'll say action, and for now we'll just call it action. New abstract action. And an abstract action basically just gives you a whole lot more power, if you will, of what you can do compared to some of the standard actions like we used with the buttons. And we're going to go ahead and do another public override. So we have to say override public void action performed. And then here this will be an action event arg0. And for now we're actually just going to leave the action itself blank because there is no action that we want it to take right now. We just want to be able to have access to the abstract action later. So we'll import all of that. And then what we can do here is we need to actually create a table cell listener. So table cell listener, TCL, and this is actually listening to the cells specifically. So the other one is listening to the data model, but we actually need to listen on the specifics. Now, this is not a default existing here, so we need to create table cell listener as a class. And now in this class, we have a whole bunch of code we need to write. And I'm just going to link to the file to download for it. You can find it either just searching online, but the basics of it is that we're using a public class here. There we go. And what we do is we create some little methods in private and public variables such as column, old value, and new value, which is going to be real important later. And then this overrides the method so that whenever a property changes here, it can get the property name. If it's editing, I can run the processing start, which comes down here and it invokes it. Basically, it does a whole lot of our back-end work here to get the old values and the new values. So here's the function where it creates the new values when it's stopped. And again, this is after validation. And then here is the old value. As soon as it runs, it gets the old value. So over here, that's what we can do. Now we are implementing the listener. Let's see, what is this? What did I type wrong? Alright, and then it's warning us now that we never use TCL, which is our table cell listener. And where we're going to use that is down here. So what we want to do is when the cell is updated, we can go ahead and say tcl.getOldValue. And this will tell us if anything has changed. So we'll do a system.out.println. And that should print out the old cell value. And then we can also go ahead and do the string value of whatnot to show the new one here in just a minute. So first we'll launch this and we'll say, okay, so Brian Green here. Move that to the side. Alright, so it shows the last value is Brian Green. So now let's go ahead and just change that to Brian. And what it says is, alright, the last value is Brian Green, it's 14. Now we go back in. Come back out. Now it knows the last value is Brian. So that's how we're going to be able to tell if the data in the cell has actually changed from the data since in the SQL table. So now we have to throw some logic in here. When the table updates, so we know that it's updated or something has changed with the cell, we need to go ahead and grab the new value, which is our tcl.getOldValue, and our new value. So we'll say if the string.value of tcl.getOld, and the reason we use value of is to actually compare the strings in their identical format regardless of it's an object of a string or the string itself. And get value of string dot equals, and that's where I'm saying that way we can compare an object that's a string or a string itself. Value of table dot get model dot get value at, and this get value at lets us actually grab the text from the first row and then the column index, which will be the e.getColumn, which comes from our event arguments. And let's see, we got a whole bunch of extra. Alright, let's go over that again. So if the string value of tcl getOldValue, so that's the last value, equals the string value of table.getModels.getValue at our row, our column, then we know that they are the same. So what we can do is a system.out.print same. If they're not the same, that will trigger our else statement, which we'll call our update SQL function, but we don't have an update SQL function yet. So that's the next thing that we need to write here. So heading down here, we'll go ahead and we'll create another public void. And we'll call this one update SQL. And we're going to need to take some parameters here, a couple actually. We're going to need the string of the row ID. We're going to need the string of the person's name. And we're going to need the string of the occupation, or the awk. The reason for this is we need to know what data to actually upload to the database here. So with that being said, what we can do over here is say, let's create some new strings. So the first one we'll call row ID. And we'll set that equal to the string.value of table.getModel.getValue at, and then we'll leave the row ID as is, e.getFirstRow. And then the column we're actually going to hard code because we know that 0 is always the column for the row ID. And now we can copy and paste this down for two more, because instead of row ID we're going to have name, which we know is always in the first column, And then we're also going to have the occupation, which we know is always going to be in the third column. So then we can send as our arguments row ID, name, and the occupation. So we'll actually have some data to upload. Coming back here, I'm just going to grab these first 3 lines and copy them, because this is the class declaration, connection creation, and then the statement. We'll add a throws declaration and a throws class exception. Now, what we can do here is go ahead and create our actual update command, which is a pretty simple one. It's just the stat dot execute update, and then our SQL, which in this case will be update table. In this case, it's called people. Set name equal to whatever our name is, and we'll put a single quotes around that. So name, comma, occupation equals awk. Then we can say where row ID is equal to row ID. Now, theoretically, when we run this statement, it'll run through and it will update all of our row IDs here. We'll go ahead and toss this into a try, just so that it's happy with us. If there are any errors, it will catch them. Yeah. Alright, so that will give us the ability here to now update. So if we go ahead and run this, and say I want to update Pythagoras from number theory to math guy. Can close and reopen, and now it says math guy instead of Pythagoras. And so now we have our update, our delete. We pretty much have everything. The only thing we might end up doing would be add something like a save or an export button. I mean, there's a whole bunch of different options that you could do. Adding a new entry would probably make sense, so that you could click a little plus button or something and put in a new row. But this is the basic of the Java Swing and SQLite combined into one useful package. Thanks for watching.